Welcome back dear all for the second session of the flexible connectors, that is the belt drive. So in the last lecture we had completed up to the types of the belt and types of belt drives, and the last one we had learned about is fast and loose pulley drive. So the next session is the problems in the belt drive. So first one is the slip in belt drive. So that the belt drive is a friction drive. So sometimes the frictional grip becomes insufficient between the belt and the pulley, and due to this the forward motion of the driving pulley may happen without carrying the belt along with it. As well as the other thing that may be possible is the belt is moving along with the driving pulley, but the driven pulley does not move forward along with the belt. So that may result into the slippage, that is the motion of the that is the power not getting transmitted from the driving pulley to the driven pulley with the help of belt drive. So that is called as slip. So due to this, the speed ratio between the driving pulley and driven pulley will change. Ideally speaking, there should not be any slip present between the belt and the pulley, and whatever is the motion to be transmitted from the driving pulley, it must getting transmitted to the driven pulley. But due to the slippage, that velocity ratio or the speed ratio gets affected, and the speed ratio due to the slippage between the driver and the belt, or the driven pulley and the belt, will be given as this relation. See this relation, n2 upon n1. So this is the ratio of the speed of driven pulley to the driving pulley, that is equal to d1 upon d2. So d1 is the diameter of the driving pulley, whereas d2 is the diameter of driven pulley. S1 is the slip between the driver and the belt, and S2 is the slippage, percentage slip present between the belt and the follower. The slippage is mentioned in terms of the percentage slip. Now what is creep of a belt? As we know that in the belt and pulley system there are two sides of belts. One is called as tight side and other one is called as slack side. Now when the belt passes from the tight side, then this side is having higher tension as compared to the slack side, and as we know that the material of the belt is somewhat elastic because of its material like rubber and the fabrics. That's why it due to higher tension it can elongate. So when the belt passes from the tight side, then due to higher amount of tension the length of the belt increases slightly. Similarly, when the same belt is passing over here from the driver, and when it comes to the top, then as this is the elongated portion due to higher tension, and from the top there is lower tension, then due to lower amount of tension the belt come back to its original position. That means on the tight side it elongates, and on the while release, at the point of release, it releases, or its elongation come back to its normal position. Due to this extension and relaxation of the belt, there is some relative motion between the belt and the pulley surface. This relative motion of between the belt and the pulley surface due to the elongation and relaxation of the belt is called as creep of the belt. This relative motion is called as creep of the belt, and due to the creep of the belt the velocity of the belt slightly reduces, that somewhat affects the velocity of the driven pulley and simultaneously reducing the speed of the driven shaft. Considering the creep, the velocity ratio or speed ratio between the driving shaft and the driven shaft is given as n2 upon n1 equal to d1 upon d2, where n2 is the speed of the driven shaft, n1 is the speed of driving shaft, d1 is the speed diameter of the driving pulley, and the d2 is the diameter of driven pulley, into e. E is the Young's modulus of the material of the belt, whereas square root of sigma 2. So sigma 2 is stress on the slack side of the belt, and sigma 1 is the stress on the tight side of the belt due to the tension.